we want to discuss this particular question on Summer 23, Paper 42, Question 2c on the drawing of the 4 stereoisomers given. Now, the complex formula given over here, as we can see, you currently now have 2 water, which is 2 aqua, and then you have a C2O4. This is your bidentate, which is the oxalate ion, or so-called ethane dioate ions. So let me draw for you here. This is your oxalate ion, and this is your bidentate. You can see these are the 2 oxygen that uses these 2 lone pair to clamp in the octahedral structure. So you have 2 water molecule and you have 1 oxalate ion, which is a bidentate, and then you have 1 bromine and 1 chlorine. So aqua or water, it's monodentate, and you have 2 of them, and then you have a bidentate that contributes to 2 lone pair. So therefore 4 leg of the octahedral is consumed, and after that you have a bromide and a chloride, which is a monodentate and a monodentate. So total you have 6 lone pair in the octahedral complex, all right, or structure. So we want to draw the 4 stereoisomerism. Now, I'm going to break it down very systematically on how you can do this instead of you simply inserting things in, which you can, all right, and then you just hope your structure will be correct, okay? So how do we do this systematically? So first, your examiner allow you to use the O bracket or O curve O, okay, so which is this part here. They allow you to use this one to represent your ethylene diamine, and they have conveniently clamped the bidentate for us, okay? Now, all we need to do is to fill in the H2O and the bromide and chloride, okay? So they wanted us to draw a form. Now, we're going to do this in a very structured order manner. So first, I'm going to draw a table. We have the H2O, okay, and we have the halides. Okay, so the halides, which is the bromine, okay, and the chlorine. If you can see on the top right corner, it's basically I just written bromine and chlorine, that's it. Okay, now, so maybe I just shift to the left a bit, then you can see. Now, so what happened here is we want to draw the 2 water molecule and the 2 halide, because you have 2 of each, right? 2 water molecule, and then you have 2 halides times 2 here, right? Now, what you can do here, you can align them very systematically. You can do a trans for the 2 aqua molecule, and you can do cis for the 2 halide molecule. So you have a TC, okay? And then you can do another one here called the cis for the aqua molecule, which is 90 degrees apart, and you can do a trans for the halide. So it's like your probability here, CC, TT, TC, and CT orientation. Okay, now, so first I'm going to do the number 1. Okay, I'm going to draw number 1 here. This is isomer number 1. First, I'm going to draw the 2 water molecules in trans so-called structure. So let's put the H2O here. Make sure you join the oxygen to the bond. So this is 2 water molecule in 180 trans configuration. And the 2 halide ion, all right, you can put it in a cis format here. So let's draw one Cl and one Br. Now, just in case if you're wondering, can I put the Br here and can I put the Cl here? It's the same thing whether you draw the first version or the second version. It's because they mirror effect and symmetrical. When you flip it the other way around from one of the structures, it will be the second one that you draw. So it doesn't really matter whether the Cl or the Br is up or bottom. It's the same thing, okay? So let me just erase these. All right, so this is one of the isomer that is the answer. Now the second one, okay, which is number 2 here, this time we would like to draw the water molecule in cis format, okay? So we're going to draw H2O here, okay? And this time, the 2 halides, we will put it in a trans direction, okay? So same thing, can I put the Br on top and the Cl below? The answer is yes, because when you flip it like this, is the same thing, okay? So that is the 2 out of the 4. This will be the easiest 2 to come up with, all right? Now, subsequently, we want to do the 3rd one and the 4th one. So this time, we're going to open up very detailed. We're going to do cis. Now, there's no trans configuration here. It's because the printed drawing for Earth inhibit us from drawing 280. So you look at the cursor here, you only have 180 here. That's possible. And the other one is forced to be 90. So it's not to say that we do not want to do a trans for the two aqua and trans for the two halide. It's not to say that we don't want to do. It's more like the question does not allow us to do two trans. Okay, so we only left with two cis. Okay, now the two cis, we're going to break it down very clearly now on how to draw the two cis water molecule followed by the two cis Br. Now, the first one we can do here is to put the two water molecule on the front and the top position. So, for example, I want you to look at this one. I'll put the water molecule here. Front and top specifically. So this is 3A. Okay, I'm going to draw a 3A out. So I'm going to point to the audience. One of the water molecule here is pointing to the audience, the front one, and I'm going to put the other one at the top one. This is also cis. They are 90 degrees apart. Okay, so we put the front and top for the two aqua, which is cis related. Now then, we will just put the Cl and Br randomly. So we would like to put the Cl here and the Br, which is also cis configuration. Okay, so here you can, I will just put something here called like for example, I put Cl and Br. Okay, maybe I'll just put CLBR doesn't have to put the position and back bottom, because if the aqua is front top, that means the CLBR should be back bottom. Okay, or maybe if you really want to, okay, fine, then we will just make it a bit more detailed. The back pointing to the backstage and the bottom. So now the back is the chlorine pointing to the back. As you can see my cursor here, can you look? Chlorine is pointing backwards, backstage, and the bromine now is bottom. Okay, like this. Okay, and then this is one of the cis drawing. Now you can come up with another isomer by just changing one thing. All right, you can come up with isomer 3B, which is another type here. What you do is you remain the front and top, which is, for example, you remain the two water molecule, the front and the top. And this time I would like you to swap these two around. Okay, I want you to swap, where the bromine now is pointing backstage and the chlorine now is pointing downwards of the octahedral plane. So let's draw the bromine pointing backstage, and let's draw the chlorine pointing downwards. Now I want you to look at the 3A and 3B drawing. Just look at 3A, 3B in the box diagram. Do you realize they're totally different? Okay, they're totally different. You can try to rotate 3B and see whether you can rotate the structure like this, or you can rotate the structure like this, okay? Or it can be this way on the plane, all right? See whether does it coincide, or so-called it looks something like 3A, so it will not come out something like 3A, okay? So if you want to answer the 4 already out, but actually there is more combination, all right? So I'm going to continue to make it the full-fledged or the possibility can come out now. So I'm going to answer 3C. Now, 3C, okay, if we want to design some more, which there is, okay, the third one is also under cis, but then this time the two water molecule, I would like to change one thing. This time, I would like to change here, okay? I'm going to put as front and bottom. So what I did is I changed this one the other way around, okay? So let me just maintain this color as blue then. Front and bottom. Okay, so now I'm going to quickly draw two template out. Okay, I need another two more. Okay, so now I've completed the two template, and let's call this 3C on top here. the 3C isomer. So the two water molecule now, I would like to put it pointing to the audience in front, and I want to point it downwards. Okay, so I will do the same likewise for the D version. Okay, so okay, bond pointing to the oxygen, please. All right, so front and bottom. Okay, front and bottom. So front and top, which is a 3A, 3B version, front and bottom is different after you put the halide. Before you put the halide, in, then it looks the same lah. Okay, yeah. If we don't consider the halide, if we just look at over here, look at the cursor here. If we just look at only the bidentate with the front top and the front bottom, right, it will look the same. But after putting the two chlorine and bromine in, then it will look entirely different. Okay, so now we're gonna fill in the chlorine and bromine now. Same thing. We just randomly put chlorine at the back. Okay, but of course now this part should be top already. Correct? So this will be back. Okay, the one at the back should be chlorine. The one on the top would be bromine. Okay, so number 3C, I put chlorine pointing behind, and on top is bromine. Then after that same thing, you swap. Because from 3D to 3C, I status quo the two water molecule and I swap the halide. Okay, 3A, 3B, swap halide. 3C, 3D, swap halide. Correct? Then the question now is, what's the difference between AB versus CD? AB versus CD is where your two water molecule is pointing at, either front top or either front bottom version. So this time I'm going to swap where the bromine now is pointing back, which is structure 3D. Let me just label, this is 3D. The bromine now is pointing backstage. And the chlorine now is pointing on top. Okay, there you go. There are total 6. Okay, 6 possibility. All right, and this is the 6th answer in the marking scheme if you were to open the PDF copy of the marking scheme. These are the 6. Now, I have systematically show you how to actually find all. What we do is we change one thing at a time. Okay, first we do cis trans, okay, trans cis, all right. Then after that we do cis cis. After that we need to subset the two cis cis of the two water molecule and the two halide molecule. Now, for those who are opening up the marking scheme and comparing your answer to whatever you're looking on the screen, just so you know, okay, I will fill in for you. Now, this answer is isomer 1. Okay, this is isomer 1 in the marking scheme. This is isomer 2 in the marking scheme. And the one that I draw for 3A, this is isomer 4 in the marking scheme. This one is isomer 3. Okay, and this is isomer 6. And this is isomer 5 in the marking scheme. But what I did was I just draw it according to a system, all right, that I have arranged nicely out. Okay,